Hello, this is our project on low power sensor networks for smart farms. My name is Adrian Cabrera.
I am Valentina Montero.
And I am Brian Mercado.
Implementation of a low power wireless sensor network for smart farm applications is a research paper written by Renan G. Baldovino, Ira C. Valenzuela, and Elmer P. Dadios. The research paper talks about using a wireless sensor network along with a low power wide area network to create a reliable wireless communication system. A WSN can consist of thousands of nodes. A sensor node collects data from the environment and sends the data to the sync node. The system used for the study uses multiple nodes. Each node has one or more sensors, wireless communication devices, processors, and energy source. The study uses a smart farm as the application platform for the study. Also, monitored environmental parameters such as temperature, soil moisture, and humidity. The system uses actuators for controlling water pumps and solenoid valves. Also uses multidisciplinary fields in order to create a smart farm. The fields that are used are robotics, agricultural automation, precision agriculture, and management information systems. The objective of the study is to demonstrate the performance of a wireless sensor network using a low power wide area network. This is accomplished using IoT devices like the Arduino, Raspberry Pi, sensors, and networking devices. A smart farm is created in order to demonstrate the performance of the system, as well as demonstrate that the system can control different application nodes using wireless sensor networks and low power wide area networks. Wireless sensor networks. In a wireless sensing design, the controls are considered the greatest technical challenge. The need to monitor real-time environmental parameters and control actuating parameters. Also, the network must have a prioritization protocol that depends on the design rules. Swakanto and everyone else that worked on the project proposed a decision support system with IoT approach to help farmers perform task management and planning, distribute information, and measure environment factors. WSN can be classified as the follows, and this table will show you the types, the range, and the application for said wireless networks. In 2015, Arshad and everyone involved developed an Arduino microcontroller integrated with the radio transceiver module to implement a WSN into a smart farm. They used star topology to facilitate introducing new sensor modes into the network. Some of the observations were that the overloading problems in the sync nodes, overloading nodes lose more energy faster, and one of the issues was that routing design protocols are a challenge because of the network topology. Bardwaj and everyone else proposed a routing protocol for WSN and proved it improved the overall energy efficiency of the network.
IoT applications in smart farms. Smart farms consist of multiple intelligent systems and smart sensing technologies that use Arduinos and other sensors to improve quality and quantity of agricultural production. Management information systems, precision agriculture, and agricultural automation robotics all work in tandem together with our agricultural drones to use to monitor and collect data through thermal and visual imaging of the farm and of how the growth is going for the respective plants and other vegetables and fruits. Some of the materials used in this research were, as mentioned above, the Arduino, Raspberry Pis, computers with respective operating systems and multiple Wi-Fi routers and some file servers. The reason for this is the sensors like the humidity sensor, water pump, water reservoir, and solenoid valve and solar panels all had to work in tandem via the network and with the Raspberry Pis and Arduinos working as a middleman to make sure all the sensors work in tandem properly to help get the most efficient growth and production out of all the agricultural produce. Design methodology. It was designed with the physical environment as the main body, and then from there it would continue down to the controls of wireless modules through network architecture and wireless topology. The physical environment was controlled and monitored via irrigation power and lighting. From there, each Arduino controller node will input and receive sensor data from the output of the data transfers via Wi-Fi to the main processing unit, to then which our study uses a total of 6 nodes, each of which had their own respective individual sensing parameters, which all worked via the database cloud and application platforms to help with the growth and productivity of the plants. Wireless node setups. The system uses multiple Arduinos as a node controller. Each Arduino has its respective ESP8266 Wi-Fi microchips integrated in order to send the data wirelessly to the main data processing computer. The Arduino will then receive the sensor data and then transmit it via the network Wi-Fi to the main processing computer, which, as mentioned previously, has 6 nodes working in tandem at respective points. For example, one node will be power distribution, another will be water system controls, soil, moisture, water flow, and valve and pumps. One will be the control chambers for temperature, relative humidity, and lighting of the control chamber rooms. Other nodes will control lighting, plant growth, and security and live feeds of the plant's growth and productivity.
To be able to have every single aspect of this system working, there should be a great power distribution management. And so the system design had various solar panels in the field that were able to generate a lot of power that would then be used throughout the farm. And with the remaining power, it would get saved in several batteries for preservation and to be used on days where the sun isn't as bright or when there were storms and other environmental difficulties. To be able to have an efficient system, there was an important amount of voltage that was being generated because of the sun. And so the system required a PCS, or a power control system, to be able to regulate the voltage that was coming into the system and then out to the other equipment. The PCS, or the power control system, regulates the voltage and the current that is being used throughout the whole farm and the systems that my partners explained before. Here we have one of these systems. This is the smart automated watering system. You can see on the left right here that there's a smart irrigation controller which sends signals to the water pump, the water reservoir, and the solenoid valve. And then to the right of that, we have how it actually works. So on the irrigation controller, we have a temperature sensor, a soil moisture sensor, and then flow sensors, and also a real-time clock. All of that then goes to a 5B power supply and the Arduino microcontroller, which will then pass through the relay circuit and the solenoid valves, and it's all powered by a 12B power supply. To be able to have good crops in these fields, not all the crops should be out on the field. So there are temperature and light controlled smart chambers. These smart chambers have a light and temperature control to be able to grow sensitive plants like tomatoes and lettuce. These chambers work by changing the light intensity and also the temperature to be able to give the plants the right conditions at their different life steps. So when these tomatoes or these lettuces are young, the temperature and the light that they should be exposed to is very different as to their midlife and then when they're ready to get harvested. Here you can see the smart chamber and the temperature control and the lighting control. And all of this is able to happen because of the power control system. And as you can see, we have the solar panels and the batteries. So when the sun touches the solar panels, they are able to receive energy and be able to power all of these smart chambers and every other watering valve and things like that. To be able to communicate with everything or smart thing on this system, there's the ThingSpeak application data. So as you can see on graph A and B, there's smart irrigation, and there's soil moisture for the lettuce, and also water flow for the lettuce. And then C and D are for the tomatoes, and you have soil moisture for the tomatoes, and then the water flow for the tomatoes as well. In conclusion, in the same way that smartwatches and smart IoT devices or Internet of Things devices, smart farms is seeing a growth in these types of devices as well to be able to have a more efficient growth and less waste of resources like water and power and other things like this. Implementing these open source hardware such as Arduinos and software like C and Python code are able to help the farmers with everything, all the tools and the technologies they want to implement. And it makes it easier for them because since these are open source, they can basically learn them for free if they would like. And they also have the ability to repair anything they need and whenever they need it. Here are our references. And thank you so much for watching our presentation. We hope you enjoyed it.
Thank you.
Thank you.